this is Mrs. Benzing. This video is going to take us through how to calculate the standard deviation of a data set. And we are going to use our hair data set that we calculated, that you gave me in class from the survey the other day. Now let's first think logically through the word standard deviation. So if we first look at the word standard, this sort of means average. And deviation is how far you deviate away from something, right? So in this case, it's going to be the distance from the mean. So how far away you are from the mean. Now, the standard deviation is not exactly the average distance away from the mean, but that's the logical idea of what we're going to do to calculate the standard deviation of a data set. Now, in this case, we're going to use the cost of a haircut in the classroom, the standard deviation of a haircut in the classroom. So the first thing we need to calculate is the mean of our data set. So to do this, if you enter this in L1 by going to Stat Enter, which I'm going to do with you right now. So if you select Stat Enter, and then you're going to see L1. Now, if you want to clear something in L1, you want to highlight it, push clear, and then down arrow. If you deleted L1 by accidentally and push delete, where did it go? You can still pull it back. Just simply go to Stat, and then number 5, Set Up Editor, and Enter, and then go back to Stat and Enter, and there it is. So go ahead and enter your data in for the hair lengths, the cost of a haircut for our class data. Once you have the data entered, then go ahead and quit, and then we're going to do a 1 vars. I'll say this often in class because it gives you a lot of statistics at once, but this is a quick way of finding a mean of a data set. So Stat, Calc, and then number 1 is our 1 vars. The default is L1, so if I pushed enter right now, it would give me the answer, but I'm also going to call up the list, but you wouldn't have to because the default is L1, and then go ahead and push enter. And this is going to give me my mean of 19.8 repeating. So we're going to use that data set. So how would we find the average distance? Well, this is someone's hair in the class at the 16th. And this is someone's hair. Someone has, I'm sorry, not distant. Someone paid $16. Someone paid $20. Someone paid $30 for a haircut. So we want to know how far off it is on average. So let's take our haircut prices the deviation away from the mean. So if you take 16, you take 16 minus 19.9 and 23 minus 19.9 and 20 minus 23.9 and so forth, you're going to get how far you are away. Let's do that in the calculator, or you can do it by hand. In the calculator, go to stat enter, go up to L2, and we're going to call up L1 minus, now you could call up the mean, or you can call up 19.9. It doesn't matter to me. I'm going to call up the mean, but if you're not really loving, a calculator and its commands, then don't do what I do and just literally type 19.8889. I'm going to call up the mean by going to vars, and then statistics, and then right there, number 2 is the mean. So I'm just going to subtract it from the mean. Enter. Now it looks like I have negatives and positives. Why would I have negatives? Because someone pays less than the mean price per haircut in the class. And if it's positive, then someone pays a little bit, or someone pays above the mean the price of a haircut in the class. So far, let's go back to the data, and we have the difference. Now, we have these negatives. Some of them were negative, some of them were positive numbers. What can we do with that? Well, there are some cases that they use the absolute value. But in the case of the standard deviation, I have seen scientists use the absolute value deviation. But in our case, and in statisticians' case, we don't like the absolute value case, because calculus people know you just can't do much with the absolute value function. But regardless, the standard deviation actually squares those numbers to get rid of them. In fact, if you just take x minus the mean and you add them all up, you're going to get 0. And we could test that out. Maybe we'll do that right now. Go back to your calculator and let's sum up L1. How do you sum up L1? Let's do a 1 vars on L2, which is my deviations, and push enter, and you're going to see the summation here is 0. This is calculator talk for 0. This is 0.00000, 12 zeros, and then a 1. So the summation of all those values is actually 0. All right. Oops, sorry. Okay. Okay. So we're going to square these deviations. So my next step is we're going to square. We could absolute value, but we're not. Standard deviation doesn't. They don't take it. They square it. So we're going to square these values. So go to your calculator, stat enter, and let's square these deviations by taking L2 and squaring them and pressing enter. And now they're all positive. They're all positive because they have been squared. And the last step is we are going to, so far we have done this. Whoops, we haven't summed it at all. Sorry about that. Okay, so far, we've taken the difference and we've squared it. Well, the standard deviation formula is going to then find the average of our squared deviations. We're going to find the average of our squared deviations. So we're going to add up our squared deviations and then divide by n. In this case, it's going to be 9. Now, this is called the variance. The variance is the squared of our standard deviation. So our standard deviation is going to be the square root of the average of our squared deviation. So let's do that in our calculator. The good news is, by the way, is that you never ever have to calculate this by hand. We're only doing this once, and once only. The calculator will do this all for us. But it's nice to know where it all comes from. So what part are we on now? We're at this stage right here. We're going to find the average of our squared deviations. So we're going to add them up and then divide by 9. So let's do it. So we're going to add up L3. So we're going to do stat, calc, and we're going to add up L3. The 1 bars on L3. So it looks like the summation of L3 is 182.889999, and we're going to divide that by n. So, oops, sorry. So let's do that in the calculator. So we're going to do 182.888889 divided by 9. And let's square root it. And we got 4.507. So let's check it out. 4.507. So that's what I said. So that's our standard deviation of our data set. So what does that really mean? So on average, the class is about $4 away from the mean of the class of about 19.88 cents. So $19.88 is the mean, and on average, we're about $4 away from that. Now, let's check to see, drum roll please, let's check to see if the calculator calculates that exact same thing. And let's go to your calculator, and let's do a 1 bars on the original data set, which is in L1. Oops. Enter L1. And it looks like, go right here, there it is. Maybe I wrote it down wrong, but there's our standard deviation. There's one more thing I want to leave you with, and then that's it for the night. Thanks so much for your attention. There's one more thing that the textbook will share with you, and that is a standard deviation called S. And that is a different formula. So the one sigma that we just calculated is called your population standard deviation. S is considered your sample standard deviation. And there's a slight formula change to that. And in this case, it's the mean minus the mean of the sample, which is just x bar. Mean of the population is mu, but mean of the sample is just x bar squared, and then the average of that. But now you're dividing by n minus 1. We'll talk about why it's n minus 1 a little bit later on, but for the most part, just in Chapter 1 and Chapter 2, you're just understanding standard deviation as the spread of data, a way to describe the spread of a data set or distribution. All right, enjoy. I'll see you guys tomorrow.